All right, we are up and running. Hello, everybody. I hope you are well tonight. We're getting a little bit of a late start, unfortunately, tonight. Ran into some unfortunate things that we had to handle. But life just sort of happens, So, anyways, the plan is tonight we are going to pick up where we left off last night and hopefully get that little bit of refactoring work done. At least that's the goal for tonight. It's going to be a little bit shorter of a stream, unfortunately, tonight, but that's just kind of the way it works, right? So, with that in mind, I want to just quickly give credit where it's due and thank the supporters of the channel, starting with our partners. Those are our highest tier of subscription over on Patreon and YouTube memberships, and they are ARSLIA and Gorbullies Inc. And then I'd also like to thank all the other supporters listed here on the screen. They are the other tiers of support on YouTube, Patreon, and Twitch subscriptions. So thank you all very much for your support. I greatly appreciate it. And of course, I would like to thank all of the viewers, either here on Twitch or over on YouTube, when this is uploaded as an archive later on. Thank you all for being here, following along, interacting, leaving comments, all that good stuff. Without you guys, this project wouldn't exist. So thank you guys for following along. All right. So tonight, we are going to continue where we left off last night, and that is sort of refactoring this UI text into our standard UI object that we were sort of creating last night, right? And so the goal for this is basically to get all this logic moved from over here into here, and then get it refactored and set up so that we can actually treat this what was UI text as an actual UI element and be able to have that be part of our UI system and get rid of the sort of hacky nature that this was doing in the first place. With that said, in order to accomplish that, there is some refactoring that is going to need to be done. So one of the first things that we kind of took note of, and we left some to-dos in here, is we're kind of using this hard-coded built-in UI shader, which maybe is not the best thing for us to be using, but that's kind of what we're doing there. And so we're requiring instance resources for that, and that is, I think that is, let's see, for font maps. So this is for the, let's see, what do we have? UI shader. Yeah, so maybe we might want to have like a separate shader for this. So we'll kind of look into that a little bit. The biggest thing that I wanted to actually straighten around is the fact that this is using a vertex buffer and an index buffer of its own, which was fine to sort of get us up and running, but that's not really the way we want to do things, right? We should be using the vertex and index buffer that are included with the renderer, and feeding the renderer geometry to be loaded instead of kind of doing it this way. So that's the goal for tonight. That is what we are looking to accomplish. And it just occurred to me, I think the actual, the title of this stream is actually wrong. So I updated the episode number, but let's call this UI text to label refactoring, label control, right? Make it a little bit more reflective of what it is that we're actually doing. Okay, so I think it stands to reason that the first thing that we should do is go ahead and refactor these vertex and index buffers out of here and not use these, and instead use the ones that are in the renderer. And so I actually don't think we need this guy open anymore, but what I want to do is look in the front end and within the front end, we also obviously have our geometry vertex buffer and our geometry index buffer, which is what we can use here. Let's see, when we created this, whoops, basically what we wound up doing, lost my place there, label create. So when we create these, it looks like we are creating the render buffers themselves to be based off the size of the string. And then I think what we were doing was actually resizing this, right? So there we see right here, track type none, because we were basically using all of the buffer all the time. And yeah, we had text length times quad size, right? And that's basically what we were using to determine how much space we needed, right? And then our quad size, let's see, where was that calculated at? So we have our quad size is here. So we are using vertex 2Ds on this. And then 4 of those create a quad, right? And then obviously the index buffer has, I believe, 6 U32s. Yep. So we have that. And so that's pretty close to what we're already doing for geometries, right? So we could probably just make it work that way. And then when we went to render this later on, which is here, we were just calling the render buffer draw method. And we were using a 0 offset, and then you're basically saying the size is text length times index count, and quad vert count, right? Which is there times text length. And we were drawing that, which, if you recall, if we go to geometry draw, if we look here, we're essentially doing something very similar back here, right? And so we basically call render buffer draw on the vertex data. I think setting only to bind true, and then if we have index data, then we actually perform the draw call there. And so this will basically just be a drop-in replacement. We'll basically be able to just use this call to do exactly what we need to do all this stuff. And the only thing that we'll actually wind up having to do is keeping track of where we are in the buffer whenever we allocate memory for that. So we'll keep track of that. And then obviously how big the data chunk is that we have allocated. And I think as a slight optimization, what I'm going to do is when we regenerate our geometry, I think I'm only going to resize the buffer when it grows in size. So let's see, are we actually doing that? We are actually doing that in here. So here we're resizing the buffer, but only if larger. So we're already kind of doing that, right? So instead of a resize here, we would do a reallocate. We'd free the old memory and allocate the new. So again, that should be pretty much a drop-in replacement. So I'm not too worried about that either. All right, well, I think the first thing to do is kind of determine where all these things are is I'm going to go to the definition of these two buffers. And I'm just going to remove these guys. And I'm going to replace them with an offset, which, you know what, let me actually not do that here. Let me undo that. Because I'm pretty sure this uses U64s for the size, I believe, for everything. For the offsets, yeah. Okay. So what we actually want to track here is the offset and Let's see, what else does this need to draw? Vertex buffer offset and the count of vertices, right? So it should already have... Oh, that's kind of an interesting conundrum, though. So we might not actually be able to do this properly. So we do use the element count here as well. The problem is I think this uses the same buffer size internally for everything. What is it? Buffer draw. So we pass the element count. Internal data handle. Offsets. So we pass the offset there. And then when we draw, we just take the element count. Draw indexed element count. Okay, that makes... Oh, we're probably going to get away with it because of the index count, I'm thinking. But then when we create... Let me see something real quick before I say something out of line that's wrong and I confuse things. So... usage... Okay, I guess it actually doesn't matter. Okay, I was thinking that the individual element size was going to matter, but it doesn't look like it does. Okay, all right. So my worries are for naught for that. I was thinking that I was like, wait a minute, if I'm going to be dealing with 2D vertices within the same buffer that uses 3D vertices, that might be a problem, but it's not going to be a problem because we index everything, and the indices take in the offsets, and then as far as the shader knows, it kind of knows how to format that data in the format that it needs, whether it's vertex 2D or vertex 3D. So I think we should be fine. So I guess all we would really need to do, we have so we'd need to create one of these geometry render datas, set an index count, set the vertex buffer offset and the vertex count, set the index buffer offset and the index count, and that's actually all we need. So actually, we don't even need a pointer to the geometry or anything, which actually raises a decent point. Because we have this geometry render data, right? Do we even need the pointer to the geometry here anymore? Or should we really just be storing, instead of having a pointer to the geometry to get this stuff, like should we just be passing index count, index offset, vertex offset, like all that information, and just do away with the pointer to the geometry. I'm actually thinking that makes a lot more sense. Because otherwise here we're going to have to create a geometry render data, create a pointer to a geometry that doesn't exist, or create a geometry in here, which is constantly going to be updated, so that's kind of dumb. I think we can simplify this a little bit and actually get away with it. Let's try that and see how that's going to work. I'm going to comment that out for right now. And let's see. We need... Let me go to definition, actually. So instead of... I need this back for a second. So really what we need is... I think just this stuff down here. So I'm thinking if we grab this... And we probably don't even need the vertex and index data itself, right? We don't even need the pointer to that. I think we can literally just work with this. And then get rid of geometry. And go back to the front end. And get rid of this guy. My cat's going bananas in the background in case you're wondering what all the ruckus is. Okay. So we've got that. This is actually way better because we can actually get away with not having to use geometry at all back here. We don't need a pointer to the geometry for this stuff. We can just take a copy of the data and draw it. So that actually winds up being a lot cleaner than I initially had anticipated, right? So if we extend this over a bit so we can look at this. So all we really needed, right, was the vertex buffer offset and the vertex count, the index count, and the index buffer offset. So we had no reason to have a pointer to that geometry in the geometry render data anymore, which I think is way better. Okay. That means we could probably get rid of a whole bunch of geometry pointers, which we kind of needed to do anyways at some point. So that's kind of awesome. Let's see, did that break anything else in the front end? I don't believe it did. Okay. I think before I move on, I probably ought to build this and see what all it broke. So let's actually clean and rebuild everything. Trash can, hey, how's it going? Good. Going pretty good. Got a little bit of a late start tonight, but we're going well so far. Can't complain. Oh right, we moved the UI text stuff and okay. So let's actually keep this over here. Font system. I didn't even think about this when I moved UI text out. All right, this is probably going to cause some issues here. UI text type, right? Oh, and this is doing all kinds of stuff with UI text it shouldn't be doing as well. Boo. We're going to have to refactor this too. Okay. You just finished writing the boilerplate to build a graphics pipeline in Vulkan, and I'm impressed with the amount of required code. Yeah. Wait till you go to make that pipeline configurable. or better yet, support dynamic state. That gets fun really fast, especially with all the fallbacks you have to do for that. We spent a lot of time on stream doing that, actually, fixing that. And heads up, if you plan on supporting Mac through Molten VK, you're going to be doing a lot of that. You don't even have descriptor sets yet? Nope. That's a whole nother battle, too. Believe me, I am well aware of the pain. Okay. So, this is setting a font data pointer. And returning true. This is setting, that's going to be a font data pointer as well. So really what this should be doing is probably returning a font data pointer. For now. That's going to be how this is going to work. So instead of taking a UI text here, we're going to do this. Get rid of that. And we probably ought to put, like, instead of a UI text type, we should probably have like a font type. I'm thinking that's probably going to be the way to go. So I guess here. So we don't need this UI text anymore. I guess we can put it up here. So we'll say type def, enum, font type, and we'll say font type. Wait, do we already have this? You already have that defined somewhere? Really? I didn't think we had that defined, but okay. Let's delete this then. I'll be dipped. We do have it. I completely forgot that we actually defined that. We should be using that instead. Okay, so this is going to take font data. It's going to return a font data pointer, right? So we're going to say a pointer to font data if successful. Otherwise, 0, null. And instead of text, we are going to take type and the type of the font to acquire. Okay, that makes sense. So I want to actually go acquire. So this takes font name, size, and font type. And then here we can just say type font type bitmap or type font type system. So that resolves that. And then we can take this and return it instead. So we'll say return that. increment the reference, and then we return a pointer to it. So that fixes that. I don't know why I didn't write it this way to begin with, to be completely honest. So we search the font size variance for the correct size. Okay, so this means that we found the size. So we just basically need to do the same thing here. So return that. Increment the reference, return a pointer to it. And then this is also going to be the same thing. I think if we reach this point, the font size variant doesn't exist, create it. Okay, so we'll go ahead and do that. So that's going to be the same thing again. So paste that, delete that. Okay. Use the type there. Change this to return 0. Which technically false equals 0, right? But let's be explicit. Okay, so that should fix the font system. Alright, so let's build again. That's surely going to break some other things that are actually using it, but that's fine. Oh, it actually didn't. Okay, so standard UI is using... The UI pass is actually using UI text, so we need to disable that. Right, so we can get rid of that. And this is one of those to-do items anyways that we wanted to treat a little bit differently, so... geometries... we're going to have to update this logic as well. But let's do the bitmap text stuff first, right? So we actually don't need to do any of this. But just in case there's something in here I need, I'm not going to nuke it all yet. I think that makes sense. So yeah, don't fear trash can as far as you know, writing. I think once you get past pipelines and once you get your descriptor set stuff sorted out, the only other thing that takes a decent amount of code is like images around textures and stuff. And then that's basically it. Like adding other features beyond that point is kind of already building on what you have. So it's generally not that much code from that point out. Not that much Vulkan code specifically. So you're actually kind of getting there. Okay. So let's work through all the issues in here. So these geometries are geometry render datas, right? Oh, okay. So this is something I didn't consider. So when I made this change to this, where I got rid of the geometry pointer, I also got rid of the geometry's material pointer. Which is something that we need to address, but not something I want to address right this minute as part of this first round of changes. So what I'm going to do is put a to-do in here and say something like keep material ID / handle instead, because we are going to keep a struct material pointer here, and we'll call this material. Right. I don't think we have that forward declared here. Right. So we need that. So here we don't need the geometry, we just need the material. Right, so if we have that, we go ahead and use it. Otherwise, we go ahead and get the default UI material. So that should fix that issue. And that should be good for that file. So let's build and move on. We got ads. Got about a minute left on ads. For those of you that aren't being served ads right now, I like to, just pause the stream while the ad timer is running, so that way anybody that is being served ads does not miss the content here, right? Nothing's more annoying, I should say, than seeing code going on that sort of little preview that's there and then not being able to understand what the heck's going on because Twitch is covering up your stuff with ads. So we'll just let these run. We got about 5 more seconds and then we'll be good to go. All right, and we're back. So this SUI label file is going to be a problem, right? I'm actually surprised it got that far. So I think what I might do for this, do we have any block comments in here anywhere? I don't think we do. I think I'm literally just going to copy out or comment out the whole dang file, right? So I'm literally just going to do that. And then SUI label H, I'm going to do the same thing. Oh, I can't do that because of these comments. I can get rid of these though. This is going away anyways. These files are mainly for reference anyway. So doesn't really matter what all we do with them, right? Okay, so let's build. All right, so this is kind of some of the stuff I was expecting to see. Was some of the fallout from us removing that geometry pointer, right? So standard UI system. So let's go to 5.19 since that's the first place that this is used. So we no longer have this geometry pointer, right? We actually have to fill out some stuff from geometry instead. So I think let's go ahead and just go below this and say renderable render data. And we'll do the material. Well, I guess we can do the material first. All right, so typed data G material renderable render data. Whoops, renderable render data. So we'll say vertex count is typed data G vertex count. Vertex element size. Actually, I don't think we even need the element size. Do we? I know we need the vertex count. Yeah, let's take the element size. Vertex element size, and then vertex buffer offset. That's the more important one. Vertex buffer offset. I don't think we need the element size, but we'll go ahead and take it just in case. And then do the same stuff for the index count, index element size, index buffer offset, and index count, index element size, index buffer offset, right? So those are the pieces of data that we need now instead of this. And I suspect we're going to need this a couple more times. So let's go ahead and grab a copy of that. So let's see, 642. So that line number is probably going to be a little bit off now. So here we go. We need that here. And instead of type data G, it's going to be type data nslice dot G, right? So nslice dot G, right? And we basically just want to, oops, nslice dot G. And we'll basically just do the same thing for all these guys. And that should be good for there. So let's go ahead and grab this. And we want 770 as the next line. Probably gonna be a little bit further down. Okay, so font system acquire. So this is that other API change that we just made for the font system. We have typed data that we pass in. And then we have type. So I think what we're going to be looking for here is actually, we want typed data equals that, right? And then we can say if not typed data, then we're unable to acquire the font. And then this is going to be type, which is SUI label type. So we actually don't even need that label type stuff. Let me actually get rid of this real quick. So we created this last night. We added this. And really, we don't need that. What we need is what was it, font type? Right? So we need that, which means that we need I think I actually created that type here too last night. Where was that? Yeah, so we don't need this. This should be font type. Right? So we have font type on that. On the internal state, we have font type. We can already just reuse that as is. So we set the type here. We also use the type here. I guess we could say typed data type, right? Just to be a little bit more explicit. Okay, so we acquire the font. That should be good. Let's see what the next set of errors are. Okay, so line 813, so it's basically where we're at. Okay. So I think the next thing that we're literally going to have to deal with is this business here. So the problem with this is, like, we've already mentioned that we want to use the render buffers and the render front end, but I don't think we actually have a way to access this data. So here's all the render buffer stuff in general. This is all shader stuff. Okay. So we have geometry upload, which essentially does what we need, right? So it allocates, loads buffer, and loads data into the range for the vertex and the index buffer, which is great if we're working with geometry. But what if we want to actually do those things individually, right? We don't really have an entry point to do that. Now, arguably, we could create a geometry object and manage that in here, right? But we don't really need to. And so I think what I'm going to do is I'm actually going to refactor this a little bit to expose the ability to be able to upload vertex and index data individually. And I'm trying to think if I should leave this one as is or just... I think I can leave this as is. And the thing is, do I want hard-coded, like hard API calls for this, right? Do I want to expose a method for... one method for the index buffer, one method for the vertex buffer? Or I suppose I could provide one method, say what type of buffer we want to upload to, get the internal buffer based on that, and then this logic is largely the same. And I think at that point we could reuse the logic, right? Because this and this are basically the same logic. And do I really want to do that though? Because these are also sort of on the front end. Or do I want to just like get a way to return a pointer to the buffer and just do all this from the front end, you know, do all this from outside? That would probably be more flexible. Less assumptions being made. So literally what I'm thinking is, let's see. So we have the creation, geometry vertex. Okay, so I guess what we can do, we'll return a render buffer pointer, and we'll say renderer buffer get. And then we can say render buffer type. And we can say if type equals render buffer type vertex, return the address of I need state. Return the address of state pointer, geometry, vertex buffer. Else if type equals render buffer type vertex. Why am I doing this with this? This should be a switch. Right? This should be a switch. Switch type. Case index, return state pointer, geometry index buffer, default, k-error, unsupported buffer type, and then we'll just treat that as a number, spit out type, return null pointer. That makes more sense, I think. Because then all we have to do is we don't have to do any of this creation business or binding business, right? Because we're not dealing with new buffers, right? So we can actually get rid of all this. Don't need it. Actually, wait a minute. Do we have the... So we just create this here, right? But... Okay, yeah. We don't need that stuff there. We can figure that out later. So at this point, we're creating it, we're not loading it. So we don't actually need to upload that data yet. We can do that here. So we can say if, let's see, if typed data text. So if we have text, then we can say, oh, you know what? I need to actually add this to. Need to add this to the front end. All right, so it's going to be right here. Let's put it right here. Export it, right? And yeah, we'll call it render buffer get, render buffer type. Attempts to retrieve the renderer's internal buffer of the given type. So param type the type of buffer to retrieve, and then returns a pointer to the buffer on success. Otherwise, 0 null. Okay. So we have that. So we'll say render buffer vertex buffer equals renderer buffer render buffer get. And then render buffer type vertex. I don't know why my telsense stopped working, so let me relaunch Vim real quick. Right, so we have the vertex buffer, index buffer, right, so we get those. And then we'll basically upload the data at this point, right? So we'll need to look at what geometry upload is doing. Okay. So we have this re-upload logic that we need to think about. Really, the only difference with re-upload is this allocate, right? Whether or not it allocates. We're only going to have to do allocates on this if we have to resize to grow larger, which we'll know when we have to do that, or we'll have to allocate here. So I'm actually not going to worry about the re-upload logic here. I'm just going to do this, and then say vertex buffer, right? And so our vertex size is going to be size of vector vertex 2D. And then we need something to store the offset, so that's going to wind up being the self. Actually, it's going to be the type data, rather. Vertex buffer offset. Didn't we already have... I thought we were already keeping that. Oh, did I not save that? I thought I removed these. So we need a U64 vertex buffer offset and a U64 index buffer offset. Right? So we allocate to there. And then why did it start deleting that? Let's just say allocate space in the buffers, right? So we're only going to do this if we actually have text. And I guess we should also say and type data text sub 0 is not equal to 0. In other words, we're not dealing with an empty string, right? So this is going to be SUI label control load failed to allocate from the vertex buffer. That should be the renderer's vertex buffer. Okay, and that can cause that to fail. So that should be fine. And then we can pasta the same thing down here. We'll change this to index buffer, size of U32. Index buffer offset. Index buffer. All right. So now instead of dealing with separate vertex buffers for this, we're actually using the ones that the renderer provides for us, which is much better anyway. Okay. So that handles the load. Not completely, though. So we need the size, right? But we also need... we need the length of the string, right? So actually, oh, right, we need to take the quad size into account. Didn't we have quad size up here already? Thought we did. There it is. Let's take our good old quad size and put it down here. So actually this is going to be quad size times type data. Do we have our text length in here? Probably not. No. Okay. So we need to get that. Let's put this in here. And we'll say U64 text length equals string length type data text, right? And so we'll actually need to do text length here, right? Okay, so that's actually what we need to allocate. We need the quad size times the text length, which is how many characters we have. And that'll give us enough data for that. And then I thought I had... So static const U64 index size equals size of U32 times 6, right? Because we need 6 of those per... let's do quad vertex size and quad index size. Right? This way we can be a little bit more explicit as to what we're doing. Quad index size. Okay? So it's going to be quad index size times text length. So for each character, we need this much vertex data, which is 4 vertices. And we need this much index data, which is 6 indices for each character. Okay. That is correct. Smudge, how's it going? Good to see you. Hope you're doing well. Welcome back. We are just doing some refactoring, which is leading to some other refactoring, but it's all good because we're simplifying things in the process, which is awesome. Okay, so unload. unload is currently destroying buffers that we don't have any longer. So what we need to do is, so we have this text length here, which is fine for the initial allocation. When we do a set text, we regenerate the label geometry. When we do that, we say vertex buffer size. So we're doing it based off of buffer size, not string length. So that's how we're getting that. So we're not going to be able to do that anymore. So we're going to have to do, we're basically going to have to keep a running text length. Like a running max text length is what I'm thinking. So that we always know how much space we've actually allocated from these buffers, right? Because I think, yeah, and we're also going to have to know that when we go to resize too, because we can't use the total size of our individual buffers because we don't have that anymore. So we're going to need to add one more thing to our data here. So we have our text. We're going to add a let's make this a U32, and we're going to call this max text length. Right? So where we take the text, we're going to set typed data text equals string length of text. Oops, we want not text, we want max text length, right? And then whenever we set the text, we're going to take the string length, and if it's greater than that max text length, then we're going to extend that, right? So let's actually get that set up first, so that that's always going to be correct, right? Okay, so when we set the text, if the strings are equal, then we don't do anything. If we have text, we get the string length, we free the string, and then we just do a string duplicate, which I guess makes sense. And I think at this point, it's probably prudent to say if, let's see, string length type data text is greater than our max text length. You know what, we're going to need to hold on to this value. So we'll say U32 new length. Right, so if new length is greater than that, then max text length equals new length. And this needs to be typed data max text length, as does this. Cool. All right, so that way we basically make sure that the max length is always longer. And then when we regenerate the geometry, regenerating the geometry actually takes into account this. So I don't think we have a way to say what this previous value was when we call this guy. So we actually don't need the new length yet. So I suppose we could move this off to our regenerate geometry, right? Length and characters, UTF 8 length. Okay. So I guess we could put that logic here. And technically new length would be this, right? So we could use char length for this, so we actually don't need this. So we can put this here, actually, and say char length. Right, and then I suppose we could just use like a Boolean flag or something super naive to say needs resize equals false, and then needs resize equals true. And actually this set should probably happen afterwards. So let's take this and put it down here for a second. Right, get rid of that, and then get rid of this from up here. And actually we can just simplify this by saying, oops, needs resize equals char length is greater than typed data max. Right, we can get rid of that. And then if needs resize, we can do this stuff. Okay, so if needs resize. I was official. Thank you for the follow. I appreciate that, and welcome. Hita list. If you have to start a career in software development today, would you choose web dev or something else? That's a loaded question. So I would say web dev is probably, of all of the various flavors of software development, it's probably going to be the lowest barrier to entry. That doesn't mean it's going to be easy per se, but it also depends on what interests you, right? Like, does web dev actually interest you, or does game dev, or does, systems dev, or DevOps, or there's embedded development for like devices and stuff. There's so many different fields that you could go into. But I would say that web dev is probably, like, if you're just looking to use it to pay the bills, web dev is probably the way to go, for sure. There's a lot of demand for it, and so the barrier to entry is probably much lower. So that's probably what I would say, unless you're wanting to do something super specific, then I would go for that. Hello, thank you so much for this series. I've been enjoying it a lot. Awesome. I'm glad to hear that. That always makes it feel like it's kind of worth it to put out the work, right? So thank you for that. I appreciate that feedback. I always kind of hope that this series and the series over on YouTube and whatnot is helpful. So to hear that it is means a lot. So thank you for that. Incidentally, by the way, for those of you who are new to the stream, this is an interactive stream, so I do keep an eye on chat. Sometimes it might be a few minutes before I respond to something, but I do keep an eye on it. And if you guys have questions or things you want to talk about within reason that's reasonably related to this stuff, I'm always up for that. So feel free to jump into chat for that, right? Oh, and we have ads. So for those of you who can still hear me, the ad breaks basically. There's like a 2-minute timer that goes off on Twitch, and I tried to pause the stream during that so that nobody misses content. And some people get ads, some people don't get ads, some people get like half that length of ads. It varies depending on platform and locale. And so some of you will get ads, some of you won't. And so for those of you who can still hear me, we like to pause the stream so that nobody misses anything. It's only 2 minutes out of the stream, not a huge deal, but that's what we like to do here, just so that you don't see a bunch of code flipping around in the background and you can't hear what's going on, right? So we've got about a minute left on ads, and yeah, Twitch Turbo for the win. I've actually considered getting that myself, purely for the ads, but I also kind of like supporting my favorite channel with subs. So I haven't really decided like how I want to do that yet, right? Because it doesn't pay out exactly the same. But yeah, from a viewer's perspective, Twitch Turbo is absolutely the way to go. Especially if you have like two or three channels you want to support. The price of it makes sense. So we got about 20 seconds on ads, and then we can continue. Alrighty, and we are back. So for those of you who might not have been able to hear what I was saying because of ads, I do like to pause the stream when ads are playing so that anybody that does happen to have ads running doesn't miss out on content, right? Because nothing's more annoying than seeing code flipping around in the background and you can't understand what's going on. So I do realize that varies by platform and locale. So some people get ads, some people don't. But I like to pause it across the board just so that nobody misses anything. Yeah, smudge, that's totally fair. Yep, totally agree. All right, so here is basically our resize logic, right? So we say we need a resize, which technically I guess we're not resizing anymore. It's more of a realloc, right? So needs realloc is more accurate. So realloc from the vertex buffer. And this is kind of explained in the code, so we don't do that anymore. And then we'll say realloc from the index buffer. Right. And we can actually get rid of these two if conditions, because we know what those are all about at this point. So let's see. We need to change this UI text to SUI label. SUI label. Right. Fail to realloc from renderer vertex render buffer. Realloc from renderer index buffer. Okay. So I don't think we have pointers to these. We don't actually store these anywhere. I think I had to get them up here in order to actually upload what we needed to upload, I believe. Yep. So I'm actually going to snag this whole thing right here. This is actually the same logic we need. We might actually extract this out to a function just to clean it up a little bit, but for right now I'm not going to worry about it. Let's pasta this here. And we'll move this guy up here. Move this guy here. Move this guy up here. And this guy here. And string length, we already have that. That is the character length, right, that we need to go for. So, actually, no, we need to use the text length UTF-8, actually, I believe. Well, let me think about that for a second. Because this does support UTF multi-byte characters, so we could potentially move through this. Vertex buffer size. Yes, we should be using the UTF string length for this. So actually, that would have been kind of a gross bug. This should be text length UTF-8. And the reason for that is because we have multi-byte characters, and we actually want the final character count to represent how much geometry we need, right? So if we have a multi-byte character, we don't want to generate a piece of geometry for each one of those bytes. We want to generate a piece of geometry for the combination of those bytes. So the text length UTF-8 is actually what we want to use for our max text length. Which means our initial logic up here is actually flawed. So when we load this, this should be what was it? String length, UTF-8 length. That's what we want to use for that. Okay, cool. Just FYI, your voice isn't synced with the video. Yeah, something happened with my my webcam's driver that's causing that. I don't know what it is. I've actually been having a lot of driver issues lately. With this and OBS. I don't know what the heck's going on with it, but it's something I have not been able to get to the bottom of. So, unfortunately, yeah, it is out of sync. It's something I'm aware of. I think the next stream, I'm actually going to like transfer my OBS setup over to my Windows setup and see if that fixes the issue, because I've been having some driver crashes actually in the middle of the stream, which sucks too. So, I don't really know how to fix that, right? I'm afraid like maybe I could go in here. Let me try one thing that I actually happen to just kind of think about. And if this doesn't fix it, I'll leave it well enough alone. Let's try. That. That probably killed it completely, didn't it? Yep. Okay. Sweet. Now it's dead completely. That's awesome. Alright. Well, apparently it doesn't like changing settings on it while you're actually streaming. So that's neat. So I think what I'm going to do is I think I'm probably just going to go ahead and turn that off. Right? Because it's not really doing any good anyways. So I'm just going to turn the camera off. Is the webcam plugged into a USB hub? No, it's plugged in straight to the motherboard. Simple and quick temporary fix: add a render delay filter to the webcam source in OBS. Really? Well, I'm assuming that would work if the actual source didn't like completely lock up, which I think it has. I suppose I could try it though. So let's add that, and I'll just set it to like, I don't know, 10 milliseconds or something like that. Yeah, I think it's still frozen because I don't think you guys can see it either. Yeah, so I'm just going to turn it off for now. I think it's deactivate it and then reactivate it. Yeah, I've tried that a couple times, but it doesn't seem to want to do it. It's almost like the driver for it just completely pooped itself. Suppose I could just remove it, right? And then add. Yeah, see, it's still, even if I re-add the device, it's still like the device itself is foobar, I think. And actually, it's not even lit up. It's not even like lit up here anymore. So I think the camera itself just died. Oh well. I give up. Yeah, that was the fix for the desync, not the complete freeze. Yeah, so I might try that next time around. I have the filter still set up on there, so I'll try it and see if it works. Because I think the only way that I could fix this now is to close OBS, which I obviously can't do. So, Dystopia, thank you so much for the follow. Appreciate it. Welcome. We're apparently having driver issues. F in the chat for webcam. Yes, please, definitely. You know what? I'm gonna follow suit. I'm actually gonna put an F in the chat. Devices. It's always fun. All right. So where were we? We were looking at the resize logic, right? So instead of resizing, we basically need to go through and deallocate what we had before and reallocate when we do this, right? So we get this, and then we'll say, let's see, we should probably check if type data max text length is greater than 0, right? Because if it's not greater than 0, then we don't have anything to free. Render buffer free, and we want vertex buffer, and the size is going to be the type data max text length times the vertex buffer size. Wait a minute, no. We want, why did I do this differently here than I did it up there? Screw it. I'm just going to do size of vertex 2D times 4. And then the offset is going to be type data vertex buffer offset, right? So go ahead and free that. We'll want to obviously make sure that that succeeds. So we'll say if it doesn't, we'll bleat about it, but I think I'm going to try and move on, right? So failed to free from renderer vertex buffer, and we'll say size is equal to some number, offset is equal to some number, and then I guess I really should be using this vertex buffer size, right? Verts per quad. Yeah. Right, that's going to be true for the old one, but not the new one. So vertex buffer size, and then type data, vertex buffer offset. So if we fail to free that, I am going to bleat about it, but I'm not going to kick us out, because that's not necessarily immediately going to cause a problem. It will eventually run the buffer out of memory, but at least by doing this, we can kind of try to continue. So we'll go ahead and free that. And then we can go ahead and allocate again. So we can grab this and put it here. And we can save. Vertex buffer size is equal to size of vertex 2D times verts per quad times. Oh shoot, wait a minute. This is actually wrong. This is taking the current length. We actually need separate ones here. We need previous for these. And instead of using that, it should be using type data max text length. Right, so what we really want is the previous vertex buffer size to be freed, and then vertex buffer size is the new size. So we allocate from that. And then we can just say regenerate label geometry, fail to allocate from the renderer's vertex buffer. And at this point, if we fail, why are we not? Okay, I guess we don't return anything, but I suppose we could boot out at this point, right? Okay, so there's that one. We can get rid of this resize. Don't need it. Realloc from the vertex buffer. So the next thing we need to do there is basically a copy of this first. So this time we want index buffer. We want previous index buffer size, index buffer offset. Oops. Index buffer. Index buffer size. Index buffer offset. Okay, so we free the old data, and then we allocate the new index buffer size, and then that should be it as far as that resize goes, right? So that handles that. Then we go ahead and update the max length if the string is now longer. And this should not be character length. This should be what was it? text length UTF-8. Right. Okay. I think that's going to work. There may be some issues around empty strings here that I'm not thinking of. The rest of this, I think, should be okay. So we've got that all set up. We need to do some work in here around the rendering and the unloading. Which actually, yeah, we need to... What we can actually do is we can cheat with the unloading. I'm just going to copy this logic. And in the unload, we'll get rid of this allocate. Free from the index buffer. Free from the vertex buffer. Right. So I guess we'll just calculate this manually here. Size of vertex 2D times 4 times typed data max text length and you know what, we don't really care if we fail to free here. I'm not even going to bother with it. Right. So this is going to wind up being size of U32 times 6 times type data max text length. All right. So there's our unload fixed. And now all we have to do is hook up the render stuff, which actually shouldn't be that bad. So maybe have use geometry question mark here too. So we've done this part already, actually, inadvertently, so we can get rid of that. However, instead of type to data G, we should probably check something on here. What can we look at? I guess max text length, right? Would probably be the thing to look at there. So instead of geometry, let's go material first. And we're going to say material on this. We actually don't have one, because we never had a geometry in the first place, right? So that's going to be 0. Render data. So we need the vertex buffer offset is equal to type data vertex buffer offset. The renderable render data index buffer offset is equal to typed data index buffer offset. Renderable render data vertex count is going to be type data max text length times 4. Renderable data renderable render data index count is going to be type data max text length times 6. I suppose we could set the size too. I don't really think we need to, but for the sake of completeness, we'll go ahead and set it. So vertex element size equals size of vertex 2D, and renderable render data index element size equals size of u32. And that should be everything that we need to do for that, so we can get rid of that to do. Do we have any more errors in this file? We do. This should be label type. Label type? Font type? Yeah. So use that. Okay. Regenerate geometry. Okay, so this was something we missed. So we resize here, but we actually have to upload that data. Do we have... Okay, we stuff that in this, which we don't necessarily need to do because we need that down at the bottom too. So we need those scoped out here. So we could just do this. Actually, I think that's it. That's all the errors we actually have in here, folks. Let's build this. Okay. So we have a couple of unused variables. 795. Oh, that makes sense. We're not using that there. Okay. 871. Quad size. We're really not using... Oh. Should be doing that. 981. Quad vertex size. So vertex buffer size. Okay. I guess we don't need these because they're actually done up here. So I'm thinking it's that one, and that's probably also going to be this one. All right. Linker error. Undefined reference to font system acquire. Maybe we didn't export that? It's the only thing I can think of there. We did not export it. And we should probably do that for all of this stuff, actually. It should probably all be exported. Actually, initialize and shut down. No, those are internal to the engine. We can release, and verify atlas should also be exported. Okay, now we're onto the testbed library. Render data geometry is being set again. Okay, so skybox pass 141. So render geometry draw. Right, we don't need this anymore. So we can now say render data material equals ext data. Whoops. Oh, you dingus. Okay, render data material equals ext data sbg material. Render data vertex count equals ext sbg vertex count. Render data, actually, you know what, instead of, let's do this. Vertex element size vertex buffer offset, vertex buffer offset, index count, index element size, index buffer offsets, index buffer offsets. We can get rid of this now, and that should be working. And we're going to have a couple more places to do this. Yeah, and the scene pass is going to need the same changes. So not a huge deal. We can just copy this. And this is just more of that geometry refactoring that we did before, right? So I'm going to move on to the next error and come back to that, actually. Oh, actually, this is all the places that it exists. Okay, this is not a big deal, actually. So all we need to do is remove this geometry out of here. And remove this, remove that. All right, game state with the UI text. So we first of all don't need UI text. Oh, our debug console is going to have to be updated as well. Okay, this rabbit hole goes a little bit deeper than I thought, unfortunately. Not a huge deal, but I don't think we're actually going to be able to complete it tonight. Simply because I do have to work in the morning, I have to get up, so I don't think I'm going to be able to complete this in just a few more minutes, unfortunately, because I've got a few more references to figure out. So what I'm going to do, you guys have pretty much seen all the refactoring that I have to do in terms of moving things around, changing the geometry render data, stuff like that. You guys have already kind of seen all that. So at this point, I think what I'm going to do is probably complete this portion of it off camera. I'm going to push what I have now. So let me make sure really quickly that I have saved everything. Okay, so what I'll do is I'll push these changes now so that at least you guys have the stuff that we've gone over on stream. And then I will finish these updates off camera. As far as the geometry updates, the UI text updates and stuff like that. And then we will just kind of gloss over those changes on the next stream. Because I think most of it is going to be pretty much a repeat of what we've already seen here. So I don't think we necessarily have to do all that on stream. Geometry, render data, refactor. SUI, I should say UI text to SUI label conversion. Right, so work in progress for both those things. All right. Cool. So that's going to do it, I think, for tonight. Thank you guys definitely for sticking with me. And, I apologize about the shorter stream tonight, but, sometimes things just happen, right? I'm going to drop my socials here real quick just so that you guys can follow me in all these different places. And I also would like to say, if you guys haven't already, make sure you follow me here. Make sure to go check out my YouTube channel and follow me there, so that you guys can kind of get up to speed, or at least be able to get the backlog of all the content, right? Because all these videos do wind up over there. Eventually, I'm going to wind up streaming to both so that there's no backlog, right? But I don't have that set up yet, so. But yeah, that's going to do it for tonight. I am going to look and see. I'm probably going to, for the sake of supporting it and because I need to go and get some sleep, I'm going to raid Ferret Software tonight. So that's a channel I raid quite a lot because it's really good. It's a really good cause. So it's basically a ferret rescue run by another game developer here on Twitch. And he takes these ferrets in from, like medical testing facilities, abuse cases, things like that. And he basically has these cameras that are focused on the ferrets 24/7. It's a stream that runs 24/7. And he's able to use the ad revenue to pay for the food for the ferrets, a great environment for them with plenty of toys and entertainment, as well as a great home, and the extremely expensive medical care is also able to be covered by the ad revenue alone. So I think it's a really good cause, and if you check out the stream throughout the day, the ferrets will actually be out and playing in the room and eating and things like that, and it's really adorable to watch. So it's a really good cause, and yeah, so that's going to do it. Thank you guys so much. I'm signing off for the night. Good night.